Hello all, today in this video we are going to work with CNN. Previously we would have works with some ANN series, and in this work we are going to work with CNN series first with Adam. For that we are initializing and importing all the libraries which we are needed, and as same in ANN we are working with the hard disease data set only. This data set we downloaded from Kaggle. We are have just to give us hard disease prediction Kaggle. In that is we have downloaded the data set, and it is having nearly 14 entries. Among that the first 13 entries we are using as the x variable, and the last variable which is the target variable we are using as the y variable, and then we are getting the info of the data set. From that you may notice that only one variable, that is old peak, is float one, all others are integers, and then we are describing our data set, and we are just checking whether our data set is having any null entries. Since if it is having any null entries means we have to work with any pre-processing functions. And regarding the target variable, we are making a clown plot of how many zeros and how many ones is having, and you may notice that how many zeros and how many one percentage is having, and then we are making some uh, data set description of how many zeros and ones is having. And this is the heat map of the data set which we are using. Then we are determining x variable and y variable. As I said previously, for x variable we are omitting target variable and using all others one, and in y variable we are only using the target variable. And based on this x variable and y variable, we are determining variables like x train, x test, y train and y test with a test size of 0.2, that is 20% for testing and remaining 80% for training. And we are using the standard scalar to convert to vectors, and then by the scalar function we are making the x train and x test and getting the shape of the variable. And why? Because here we have to reshape, because CNN will only work with three-dimensional data. It won't work with one-dimensional data as ANN does. So we have to reshape our data into three-dimensional. So we are using the reshape function and the reshaping our data set. So this the 13 into 1 we will be working with the convolution neural network input dimension. So we are just making out our layer description for convolution neural network. You may notice that initially we have given the sequential layer, then the convolution 1D layer. Here we are giving the filters and all, then padding, activation, input size which is 13 comma 1, then it is followed by the max pooling layer with a pool size of 2, and then we are giving a flattened layer, then a dense layer with output dimension 188 and activation as ReLU, then a dropout layer with a dropout size of 0.5, and finally the dense layer we are giving the output dimension is 1, because our work is a binary classification work. If it is a multi-class work means we have to use the number of classes which you are having. Then this is the summary of our layers. Then we are compiling our CNN by using the loss, binary cross entropy, optimizer we are using as Adam, metrics as accuracy. Then we are training our model by using the fit function and the variables like x train, y train, and in validation data we are using x test and y test, and we are training for nearly 50 approaches. You may notice that we are training for 50 approaches, and then we are making a graph. Within the graph we are just describing our validation accuracy and training accuracy. For a better model, the validation accuracy should be high when compared to training accuracy, but here you may notice training accuracy is only high. For this we have to make some modifications with this algorithm that we can do in the next code. We can try some different combinations. Then we are just making the classification report. By this we are displaying variables like precision, recall, F1 score, support, accuracy, and we have got nearly 96% accuracy. And we are making a definition for confusion matrix, and by this we have making the plot for confusion matrix. So this is the confusion matrix of the CNN algorithm. In the next video we will be working with some other CNN code. Thank you.